All right, so today's the 24th, and we're just going to finish up what I was unable to get to yesterday. So let's do a quick recap of the things that you learned yesterday just to make sure. So this is just more with logs. So we'll just call it more log stuff. Boom.
What's it called?
So yesterday we learned about evaluating logarithms. Let's do a couple basic ones. What's log base 5 of 125? This is one that I bet a lot of you know off the top of your head, but I appreciate that you're looking at your resource sheets. Yeah, it's 3. And the reason for that, remember, is because if you take 5 and raise it to the third power, you get 125. So remember, when you evaluate a logarithm, you're effectively just looking for an exponent that's required to make the base equal the argument. So how about log of 100? 2. Right. Because remember, the base of this log that you can't see is 10. This is called a common log. So it's got a base of 10, and the exponent required of 10 to make it 100 is 2. How about log base 3 of 1/27th?
Nine.
You're fine. First thing we should know 100% is that our answer needs to be negative. Because remember, negative is going to what causes it's going to be what causes the number to flip downstairs and become a fraction. -3, right? So the answer is -3. Anytime you need to create a fraction, you need a negative exponent to make that happen. And remember, logarithms are really just exponents. That's all we're looking for here. At some point, time permitting, I'll show you that logarithms and exponentials are just inverses of each other. They're just flip-flops. All right. How about log base 8 of the cube root of 8? So again, this is all just from yesterday still, okay? It's good for someone who's maybe trying to get caught up on it, but good job. We remember that in order to make a root, we need a fractional exponent. And this number that I'm going to circle in green it's called the index of the root, but more importantly, it becomes the base of the fraction like that. Okay. So the answer in this case would be 1/3. A fact that we learned yesterday is that if you take 8 to the 1/3, it's convertible over into the cube root of 8. Okay. Got it? Yeah, man.
How do we know that it's one inches?
1/3. Well, let me do another example and I'll show you when it's not 1. Would that maybe help you? If you still have that question after this example, just let me know. Let's say we'll do that in a second. Yeah, I'll switch the base here. That's what today's notes are going to be is I'm going to switch the bases, but for now I'm going to make the bases match. So let's say we had log base 5 of the fourth root of 5 cubed. So what you have to identify in understanding this will make sure this will help ensure that today's notes that you see why we have to talk about this. Please note that the numbers I'm circling in yellow are the same. That's critically important to this relationship. So going back to Hugo's question, we know the answer is going to be a fraction, first of all, because we're making a root. And then these numbers, I'll color code them for you. They each have their spots. The 4 becomes the denominator, and the 3, I'll circle him in green, becomes the numerator. The reason I knew the last one was a 1, and I'm running out of colors here, but I'll put purple going back up to this problem. That was an 8 to the power of 1, right? We just don't acknowledge things like that, but that's why it was there. I, oh, how about let's do some natural logs. What's the natural log of E? I don't know what you're saying to me. You're saying that E is equal to 1? Because that's not true. E is roughly equal to 2.71828. What is the base of this log? I'll point to it right here. Boom. What's the base of that log? Nope. It's base 10 when it's like this one up here that I just circled. If it's log without a base, that's a base of 10. If it's ln, you'll remember that stands for natural log. And a natural log is a log with a base of e. So if you were, and this would help with your understanding, if you were to take this problem that I'm circling right here, you're well within your rights. Until you learn this a little better, you're well within your rights to just rewrite it like this. Log base E of E. These two things, I'm going to put yellow boxes around them. This yellow box and this yellow box are literally identical. Okay, so a natural log, ln, is a log with a base of e. So when you look at the problem in this state down here, it's almost silly. E to what power equals e? The answer is 1. All right, and that works. You can modify that a lot of different ways. I could do like log, I didn't mean to do that. Sorry, my bad. You could do natural log of like e to the 5th. What's that going to be? It's going to be 5, because all I'm asking you is e to what power equals e to the 5th. Once you understand that, you'll see what an absolutely stupid question that is. But until you do, I see how it can be confusing. Bless you. What's natural log of 1 over e to the 4th? What do we know it has to be to make it flip? We know it has to be a negative. So let's get that out of the way right now. It needs to have a negative on it. And how many e's do we need to make e to the 4th? So the answer is -4. So there's your 6-minute, whatever, how, I don't know what I just did, but 6, 7 minute recap of what we learned yesterday. So that's all stuff, assuming that you were either here or watched the video, that should be in your, I'm relatively decent, comfortable with that. So, which leads us to today. So today, what's going to happen is we're going to have bases that don't match. And the problems that I'm concerned with, that I'm talking about, they all involve radicals. So they're all going to be fractional sort of considerations. But take a look at something like this. What's log base 5 of the third root or the cube root of 25? So this is where the new stuff starts today. And what we want to be concerned with here is the fact that the numbers that I circled earlier are not the same. This and this are not the same. So a common misconception is people who kind of only half understand this would say, oh, I know the answer is 1/3. Well, that's not true. You can only get away with that because in those other problems, the bases, the things I circled in yellow, have been the same. So the trick to this, and it's not all that huge of a trick, but the trick is to do a base change. And so we're going to take log base 5 of the cube root of 25, but I'm going to rename 25. What is 25? It is. It's 5 squared. And just like that, poof, look it. I made my bases the same. This number and this number are the same. And we can sleepwalk our way through a problem like this. We know it's going to be a fraction. The question is it 2/3 or 3/2? Which one is it? So the answer is 2/3. The ability to evaluate that was predicated on your ability to take the number inside the radical and rewrite it as a power of the base of the log. It's a lot of words, but let's do another one. Let's do log base 4 of the 5th root of 64. Right. So again, the goal is to ask yourself the question, the number I just circled in yellow, can I rewrite that as a power of that number that has the arrow pointing to it? And if you look at your sheet I mean, and again, like I said yesterday, you'll memorize all these eventually. Like you, I don't, whenever you're ready, you just will. And what happens is you realize, hang on a second, I'm going to rewrite this as log base 4 of the fifth root of 4 to the what? Yeah, 64 is just 4 to the third. And once again, now you're going to notice that, hey, hot dog, that and that are the same. So I can just pull out the 3/5 and I'm done. Got it? That makes sense? Let's go again. Let's do log of the seventh root of 1000. I'm just, you can't really hit this point enough. I mean, I guess you can overdo it eventually, but what is the base of this log log? It is 10. Remember, when it's a straight log, it's not a base of e, it's a base of 10. And so, again, I'm not opposed. I've got no issues if you want to write in a base of 10. I'm not going to write it like on a test or something like that. Delta Math isn't going to write it in there for you, but you can. Got no issues with that. So the goal is to take that little red number and say, can I make the white number inside the radicand or inside the radical? Can I make that a power of 10? What is 1000? Yeah, it's really 10 to the third. Good job. So I'm going to take this 1000 and say, yeah, you're not what I want. I want you to be 10 to the power of 3. If I haven't made myself clear, those two red numbers are what we need to match. That's the key. And then the fraction will just fall right into your lap. It's just obviously boom, boom, done. Are you with me on that? There is another level of difficulty that I'm going to not give you today. Today is for doing test corrections and then working on the assignment. Delta Math has 3 levels. You'll see them, you might not even notice, but you're going to get a mixture of level 1 problems and level 2 problems. And level 1 problems are all pretty easy. They're like, natural log of e to the fourth, log base 4 of 64. I mean, simple, basic logarithm sort of understanding. And then the level 2s are the ones that contain the radicals and the base changes and stuff like that. Level 3 is something that we'll talk about probably tomorrow. So your goals for the day are to get your test corrections done. And then before I see you tomorrow, get your Delta Math done. And then tomorrow we can press on. Sound good? But yeah, it is what it is. So that's what we're doing tomorrow. I'll pause this because later on you might have a question, and I may be paused for 30 minutes, but someone watching the video won't even know because it'll just pop right back up. So